In my opinion, mixture problems are just a little bit more difficult, but not impossible. Just make sure you set up the table with the correct information, and I think it'll start to make sense after you do a couple of them. So what we have here are some walnuts that cost 80 cents a pound. So here's walnuts, and they cost 80 cents a pound. So I'm going to fill in 0.8. It also says that we're going to mix it with 8 pounds of cashews. 8 pounds of cashews, here's the pounds column, and here's 8 pounds of cashews, and those cost $1.25 per pound. So I'm going to put in $1.25 here for cashews. And we want to make a mixture that costs $1 per pound. So here is the mixture, the total mix, and we want that to be $1 per pound. What we don't know in this is how many pounds of walnuts, which gives us our X values. That's why it's going to be X in this cell. And then the total would be however many walnuts, X, plus the 8 pounds of cashews that we have. So it makes sense that if I bought 1 pound of walnuts and it cost 80 cents a pound, that the total cost would be 80 cents. If I bought 2 pounds of walnuts at 80 cents, I'd pay $1.60. If I bought X pounds at 80 cents, it would be 80 cents times X. For the cashews, 8 pounds times $1.25 is equal to 10. And then for the mixture, we have X plus 8 times $1, which is simple because anything times 1 is itself, the identity property. So I'm going to have 8 plus X or X plus 8 for the total mix. Now that I have this, I want to take my total cost of walnuts, 0.8x, add in the total price of cashews, 10, and set that equal to the mixture, which is X plus 8. And you know what to do from here. And first of all, get the variable to the same side and then isolate the variable. So you can continue to solve that one. Let's try another one along those same lines. Let's go down to number 7. It's 100 pounds of cashews and almonds. So the mix is going to be 100 pounds. So right here, mixture is going to be 100 pounds. Okay, we have cashews that cost $8 a pound. So here's cashews, those cost $8 a pound. Almonds cost $3 a pound. So here's almonds, and those cost $3 a pound. And then it says how many of each type of nut must be mixed to obtain a mixture that will cost customers $5 per pound. So here's $5 for that total mixture. And so easy to fill in the total cost here. 5 times 100 is 500. But where are we going to put that X? Remember that we always need to have an X equal something. And so we don't know how many of each type of nut. And so something that some students say, well, why can't we have this one be X and this one be Y? Well, we could use 2 variables if we were able to solve equations with 2 variables, and that's something we will learn, but for right now we're focusing on 1 variable equations. So if we have cashews and almonds together equals 100, then if cashews was X, we'd take 100 minus that to get the total of 100. Then we can fill in this other total cost column. 8 times X is 8X, and 3 times 100 minus X, you could either write it this way or you could distribute it to be 300 minus 3X. So now we have all the data filled in, and now we want to set up our equation, which is going to be the total cost for the cashews plus the cost of the almonds, which is 300 minus 3x. Again, you could either write it this way or distribute it. 3 times 100 is 300, 3 times negative x is negative 3x, and we want to set that equal to 500, which is the mixture. Okay, even if you're still like, I don't know about these, that's okay. These are, like I said, a little bit trickier, not impossible, but see what you can do with number 6. Okay, that is a similar type of problem where you're doing different types of tea, not different types of nuts like cashews and almonds, but you can try that one. And the same thing for number 5. The only thing about number 5 that's different is that I didn't set up the table the exact same way. So see what you can come up with for your table and then send me a screenshot if you get stuck. The last type of problem we'll look at is a mixture problem involving solutions. It's a different type of mixture problem, but you set it up the same way. We need this total 20 liters of a 20% acid solution. So that's the mixture we're trying to get to. We need 20 liters of it, and we need it to be a 20% solution. So you don't have to put the 0 there, you can just put 0.2. And then we also have these two other solutions. We have jugs of 10% solution and 25% solution. So we have this 10% solution and we have this 25% solution. And we need to make 20 liters total. So again, it doesn't matter if X is your solution 1 or solution 2, but no matter what you choose, 20 minus that is going to be the other solution. Now we can just fill in the table by taking 10% times X, which is 0.1X. We have 25%, 0.25 times 20 minus X. Again, you can distribute that to be 0.25 times 20, which would be 5 minus 0.25x. That could go in that box as well. And then the mixture is 20 times 0.2, which is 4. So we're going to be looking at this information right here to set up our equation. We need solution 1, which is a 10% mix, plus solution 2, which is 5 minus 0.25x, and we want that to be equal to 4, which is the total mixture that we need. Okay, again, just take your time in setting up the table, and if you get stuck, send me a screenshot and I'll kind of help you along, but those are the mixture problems.